Hello there guys, here's a quick video just to let you see a project I'm currently working on. It's a bit more fun than anything else, but early stages of prototyping this little fun project. So a couple of months ago I went through to Glasgow, and while I was there one of my friends gave me these two little boxes and said have a play with those. See if you can do anything exciting with them. So, not knowing an awful lot about them, or not being able to read the writing that's on them, I was a bit confused. I opened up the box and I saw two of these. Now, don't know if you know what these are, but these turn out to be two devices called... Can't focus at all on these things. Anyway, the writing there says SBM-20. SBM-20 from 1992-01 are it's a Geiger tube from 1990 week 1. So it's 23 or so years old today, and so I thought I'd have a quick go with this Geiger tube for a bit of fun. So very early prototype stages. Here is the messy board as I build things straight from proto board. So here is the horrible circuit to get started with. Give you an idea of what we've got here. We have an Arduino micro. Actually, is that micro? Is it a nano? Can't remember. And we have some really horribly cobbled together circuitry. The circuitry around the back here, there's high voltage transistor for generating the high voltage caps, inductor. So this board here that you're looking at here is the HT generator board. That's the board that generates the high tension, which is approximately 400 volts going out in that red wire. The sense board is this one, which basically has the return wire coming back to a resistor pull down with a diode to clamp the power to protect the Arduino. So pretty much that's the entire circuitry. The only other addition I've got tagged on here at the moment is a little voltage divider going here. So this voltage divider, I need a pointing stick. Let's find a pointing stick. This voltage divider takes the 400 volts from there, divides it down through a 10 megohm resistor, and I think that's a 39k resistor. That one's not used as a divider. Let's try that again. So we've got a 10 megohm, and this preset, this adjuster is set to 50k. So I get approximately a 200 to divide through this chain, and then I've got a high impedance resistor here feeding off to one of the analog inputs on the chip. That analog input reads through the software the voltage that's being fed to the tube. It's not 100% accurate because of losses and impedances and things, because these power supplies are very high impedance out, but it gives a very good indication as to the voltage that's going off. So there we go, we've got the HT generation through that transistor, goes out that wire, comes back this wire, goes off to the clamping diode, the pull down resistor, and then off straight back to the chip. The HT circuit is being generated HT voltage from a square wave PWM coming from the chip. So the chip's self-generating its own power to generate the HT. So in total, all we've got here is power supply out, power supply out. We've got analog return telling me the HT voltage. We've got a sense line to sense the ticks from the tube. We've got the square wave output and we've got the buzzer output. And as you can probably hear while this has been running, this buzzer is actually operational. Let me just bring a light down here. That was quite unsuccessful. Let's try that again. Let's bring a light down here. So you can see that there's you can't really see at all. That didn't work very well, did it? There is the little speaker, the little transducer, which is detecting the voltages, or outputting the pulses, I should say. No LED operation in this circuit at all, other than the software, which is just returning serial data. So, as an experiment, as a trial, you've probably heard this running in the background all the time, doing its tick, tick, tick. If I now try to focus this, I have a little radioactive element from a smoke detector here. It's Americium. It's 0.9 microcuries, so it's a very low figure, but it's alpha and it's relatively safe to be around. There it is there in that little packet. That's the hot side facing upwards. If I bring that in close to the tube, you'll hear it starts to count there. Now, the counts per minute on ambient in the background in Edinburgh here is between about 20 to 25, sometimes fluctuating up to about 40 to 50 as a cloud of radiation goes by. And the sensing on this Americium 241 on this tube, when calculated out, it comes out to between about 850 to 900 counts per minute. So it shows that the circuit is operational, and the calibration is pretty close actually. I've tested with another meter and I'm getting much the same sort of readings. So not too bad as a circuit as testing. Just going to power it down for a second and power it back up. So it takes maybe 3 or 4 seconds to actually switch on. The reason it's taking so long is that the power supply is self-calibrating through switching the PWM. So the system works out the best PWM to get the appropriate voltage out, to get the tube to actually generate its pulses. So there's a quick, very, very nasty prototype. Proof of the pudding more than anything else, isn't it? Now to make it pretty. Thanks very much for watching. If you want to see further on this one, subscribe and feel free to comment. Bye bye.